Mensuration. Introduction to trapezium and its area. There is a park near Arya's house. The shape of that park is different from any other park. Here we can see the picture of that park. Can you tell the shape of this park? The park is trapezium in shape. Trapezium is a quadrilateral with a pair of parallel sides. Observe that the park also has only one pair of parallel opposite sides. Arya wants to find the area of this park. Let us help her to find the area of that park. Let us name the vertices of the park as shown here. Let us draw a rough figure representing the park and we will name the vertices as shown here. The lengths of the sides AD, AB and BC are 20 meter, 12 meter and 30 meter respectively. Let us draw DE parallel to AB. Then the length of DE is same as length of AB. Now the trapezium is divided into two parts, a rectangle and a triangle. Now we can say that the area of the trapezium ABCD is given by adding the area of the rectangle ABED and the area of the triangle DEC. So let us first find these two areas. Recall that area of a rectangle is given by multiplying its length and width. From the figure, area of the rectangle ABED is given by multiplying H and A. Thus, the area of the rectangle ABED is 240 meters square. Now let us find the area of the triangle DEC. The formula to find the area of a triangle is given by half the height of the triangle multiplied by base of the triangle. Thus, the area of the triangle DEC is equal to half the product of H and B. Thus, the area of the triangle DEC is 60 meters square. Now, let us add the area of the rectangle ABED and triangle DEC to get the area of the trapezium ABCD. Therefore, the area of the trapezium ABCD is equal to 300 meters square. Thus, the area of the park is equal to 300 meters square. Suppose we have a trapezium as shown here. How will you find its area? In this case, the area of the trapezium will be equal to sum of the areas of triangle ABF, area of rectangle BCEF, and area of triangle CDE. Derivation of the formula of area of trapezium. When we have to find the area of a trapezium, do we have to follow the same procedure each time? No. As we have formulas to find the areas of rectangles, square, triangles, and other shapes, we have formula to find the area of a trapezium. Let us derive that formula. In the example of park of trapezium shape, we found the area of the trapezium ABCD by adding the area of rectangle ABED and the area of triangle DEC. Let us try to simplify the formula now. Area of rectangle ABED is given by the product of H and A, and the area of triangle DEC is given by half the product of H and B. By simplifying this, we get the formula to find the area of trapezium. As H is common here, we take H outside. Adding A and B over 2, we get the next step. Then we can write 2a as a plus a. From the figure, a plus b is same as c. Therefore, we can generalize that the area of a trapezium is the product of its height and half the sum of the parallel sides. Let us now solve few problems. There's a plot PQRS which is in the shape of a trapezium. The height PL is 12 units and the length of one of the parallel sides PQ is 15 units and the length of the other side RS is 55 units. Find the area of the plot. We can draw a rough figure by the given data. We know the formula to find the area of a trapezium. By substituting the values, we get the area of the trapezium. Therefore, the area of a given plot is 420 square units. The area of trapezium ABCD is 273 square units, and the distance between the parallel sides is 13 units. If one of its parallel sides is 8 units more than the other parallel side, find the lengths of its parallel sides. We can draw a rough figure by the given data. Let the length of AB be x units. Therefore, length of CD is x plus 8 units. Height is 13 units. Next, let us use the formula to find the area of the trapezium. We substitute the values in the formula. We take 2 as a common term and then cancel 2 in the numerator and the denominator. Then we simplify the equation further and find the value of x to be 17 units. The value of x represents the length of one parallel side, AB. We can find the value of the other parallel side, CD, by adding 8 to the value of x, which is equal to 25 units. Let us summarize what we have learned. Trapezium is a quadrilateral with a pair of parallel sides. Area of a trapezium is equal to height into sum of the parallel sides divided by 2.